This video is on endothermic and exothermic reactions. There are two types of chemical reactions. We can have an endothermic reaction, which is a reaction that takes energy in. We can have an exothermic reaction, which is a reaction that releases energy, so energy exits. So think of exit, exothermic. Endo is an entrance, so energy is coming in. In a chemical bond, energy can be released when a bond is formed, or energy is absorbed in order to break a bond. So a bond is strong, kind of like your bone. If I were to want to break a bone, I'm going to need to apply energy to break it. If I'm to form a bone, energy is released. So we can kind of think of bonds as bones. We're going to be able to identify if a reaction is endo or exothermic based on the number of bonds formed and broken. We can also calculate the amount of energy. Energy is measured in joules, which is shown as a capital J. Mathematically, we can solve for energy because energy is equal to the mass times something's specific heat. We'll talk about that more in a second. And its change in temperature. So my formula is Q, lowercase q, mass is M, specific heat is C, change in temperature is delta T. So if I were to write that, Q equals MC delta T. So my specific heat of water, well, I want to know what is specific heat. What does that mean? Well, the specific heat of water, the numerical value is 4.2, and its units are kind of funny. It's joules divided by grams degrees Celsius. So what that means is it's going to take 4.2 joules, which is that term of energy, so 4.2 joules of energy to have 1 gram of water, that's where my grams come from, increase in temperature by 1 degree Celsius. So if I have a gram of water, which is a milliliter, in order for me to take that gram of water, which is a cube of water, centimeter by centimeter by centimeter, if I have this much water and I want to increase its temperature from 10 degrees Celsius to 11 degrees Celsius, I need to heat it. You can use a hot plate. I need to apply to it 1 joule of heat. Then it'll go up 1 degree Celsius. So I can determine how much heat is needed to change my water using this math equation. So we can do that. In my example problem, I want to know how much energy, that's joules, is required to raise the temperature of 350 grams, that's a mass, of water 15 degrees Celsius. That's my change in temperature. So my equation, Q equals MC delta T. I'm looking for my joules is what I want to find, which is Q. My mass is equal to 350 grams. My change in temperature is equal to 15 degrees Celsius. And my specific heat is a constant. It's always going to be 4.2 joules per gram degrees Celsius. So I'm looking for Q. Q equals mass, my 350 grams, times my specific heat, 4.2 joules per gram degree Celsius, times my change in temperature. 15 degrees Celsius. I plug that in my calculator, I get 22050 joules. So that is 22,050 joules of heat that I have to apply to my 350 grams of water to make this raise its temperature 15 degrees Celsius.